Okay, so welcome. So let's just recap the whiteboard pics from last lesson. Um, in the previous lesson, we had worked with solving equations where we could convert them into some form x squared equals a, where this x represents a single math factor. So this could also be some sort of object in parentheses here. Yeah. And A represents just some number or combination of numbers, or maybe some unknown constant. But anyway, something that doesn't have any x in it, where x is the variable that we're solving for. So if we have an equation that we can convert into this form, x squared equals a, then we can use this step that if x squared equals a, then x is equal to plus or minus square root of a. Okay. Now, we know from Math 1c that we cannot take the square root of a negative number, or at least that's what we said. Okay. However, in Math 2c now, we're going to define a new concept, or a concept that is new for us, and that is this concept of this imaginary unit, which is shown in the box on page 21 of your books. So it's defined either by I squared equals -1 or I equals the square root of -1. And it's the second version that I will use, although the book often uses the other version. Okay, so what are we saying? We're literally saying that anytime we get the square root of -1, we call that I, and then we just continue just working with the I, just like it's a little bit like it's an A, that it stands for some unknown number. In this case, it actually stands for a known number, but it's a number that is not real. Okay, that means it's basically not directly observable. You can never get any measurement that equals I. You can never get, a mass of I kilograms or a length of I meters. Okay. So it's not something that's directly observable or measurable in the real world. Okay, so then we say that it's non-real. However, this allows concepts to be linked, which otherwise could not be linked. So for example, in Math 4, then one of the formulas you'll see is this one, E. Now this in itself corresponds to like a special constant, but this represents a fixed number. Okay, so E with the exponent IV equals sine of E plus I times cosine of E. Okay, where we've seen sine of E and cosine of E from a geometry perspective in our Math 1c course. In Math 4, you'll also discuss this from a more algebraic perspective. Okay, so anyway, this is one of the formulas you'll see in Math 4. And the reason I'm raising this now is because we have this I here. This I represents square root of -1. And when we have a formula involving I here, we're able to link these trigonometric expressions, or you could say trigonometric functions, with this exponential expression or this exponential function. Okay, so this I, it allows those concepts to be linked, whereas you cannot really link them together just using real numbers. Okay, so this imaginary unit is very important in various areas of math. But for our Math 2c course, we're not really going to do much more with it. We're just going to basically use I to represent the square root of -1, and then just that's pretty much all we're going to do. Okay, so let's just see an example where we solve an equation that has no real roots. So it has two non-real roots here. Okay, so then we would often say these are complex roots. Okay, non-real roots, or this I represents the square root of -1. Okay, and we're just going to see how we're going to solve that equation. Now, in order to do that, as a bit of background, we can say that if we remember the laws of indices, as laws of exponents from Math 1C, then we have this law, that if we have a product and the whole product is raised to the n, then it's equal to what you get if you raise each separate factor to the n. So specifically, if n is equal to 1/2, it looks like this. And when we raise something to the power 1/2, then we can also write that as a square root. So then we get this. Okay. So what we're saying is that the square root of a product is equal to the product of the square root of the factors separately there. Okay. So if we say, well, let's suppose this a is equal to -1 now, then we can do the same process. We can view this as a product of -1 and b. And then -1 times b, we would write that as -b. And the square root of -1, we're calling that I. So what we're saying here is that the square root of the -b is equal to I times the square root of the b. So we would normally view this as that we would, if we have this sort of situation, we could view this as a -b, where we're viewing the b as representing a positive number, and then we're saying that that is equal to I times the square root of b. And now because the b is a positive number, then this part is real, so we have some real number here multiplied by I. Okay. In this case, the square root of 16 is 4, so it comes out at 4i there. Okay. So if we just look at another couple of concrete examples here, so we're saying square root of -2 is I times square root of 2. And also if we have 5i squared, that is 5i times 5i, then it will come out as a real number, because I squared is equal to -1. Okay, so if we just run through this example, so this is of the form that I said in the beginning. It's of the form x squared equals a, where we're viewing, when we say x squared, we mean it like a single object squared, and we're viewing this as a single object because it's in parentheses here. And so then we can do the next step, that if x squared equals a, then x is equal to plus or minus the square root of a. So we're using that second step. And then now that we've got to here, then we just have to clean this up a little bit. We just basically rewrite this using I. Okay. So and this plus minus is just the same plus minus throughout here. Okay. So here we've seen the -16 is equal to I times root 16, which is 4i. And then at the end here, we just add 7 on both sides. And we normally write the I at the end here. So this becomes 7 plus or minus 4i. And then usually we write out the two roots separately as x1 and x2. So this means x plus 4i, 7 minus 4i. Sorry, 7 plus 4i and then 7 minus 4i. I've written it out in this way. Right, so let's have a look at, I think I'll make a cut here and I'll continue in the next part. Okay, so thanks for watching. Stay good.